Okay, dear students, welcome to all of you in the digital electronics class. So today we are going to discuss about the PN junction diode. As you know that PN junction is the most important structure in today's electronics. P and N are the semiconductors and we can make the several devices with the PN junction. Like the simplest device is the diode that is investigated in the 1940 when initially research are carried on in the field of semiconductor. Now we can see that later stage several devices like the transistor, FETs and other ICs we use the PN junction. So today we will see that how the PN junction work. A basic PN junction is typically made from a single piece of semiconductor. The pure semiconductor is called the intrinsic type of semiconductor. When we mix the some impurities like trivalent and pentavalent impurities, then we can make the P or N type junction. Generally, by adding the trivalent impurity, P type semiconductor is made, and by adding the pentavalent impurity in the pure semiconductor, N type semiconductors are made. The specialty of the P and N type semiconductor is that P type semiconductor has the majority carrier as holes. Holes are found in majority in the P type semiconductor, while in the N type semiconductor, electrons are found in the majority. तो our p type जो semiconductors हैं that have the holes in majority and electrons in the minority, while in n type semiconductor electrons are in majority and holes are in minority. Now we will see that what happen when first if we put the one p and n junction nearby and there is a no charge is applied. Suppose it is the P and N and we apply the no bias across the two terminal of the PN junction. No voltage is applied. In that case, we find there is a depletion region created because P has the holes in majority, N have the electrons in majority, and they combine and create a depletion region here so that remaining holes and electrons cannot cross the junction. So this depletion region work as a barrier between the P and N region. So there is a very minute current flow when no voltage is applied. Only the movement of holes and electrons is due to the environmental temperature. Now, if we apply the forward voltage across the P and N region, so we take the PN junction and apply the forward voltage. So in the case of the forward voltage, we put a battery here and connect in such a way that the positive of the battery is connected from the P side of the semiconductor and negative of battery is connected with the N side, due to which there will be current flow and depletion region will remove. Now why the current will flow we will see, because due to positive voltage it will push the holes available here and it repels the holes because it is connected with the positive terminal and holes are also positive, so this charge will repel the holes from this junction. And in a similar manner, when the N is connected with the negative side and majority carrier are electrons in this junction, and the it will move, electrons will cross the junction, so the current will flow in the circuit. Now we take the case of when we connect the reverse bias. If we connect the P and N junction in the reverse bias, then a large depletion region will created. Now what is the region of creating this depletion region? We will see that if we connect the negative side of the battery with the P region and the positive side of the battery with the N region. Now the battery will attract the holes from this side. The holes will not cross the junction and they will move far from the junction. In a similar manner, electrons move towards the battery. So, in this manner, there will be a large depletion region occur. Now, we can see it by the VI characteristics of the PN junction diode. How we can create the VI characteristics of the PN junction diode? That is also called the volt ampere characteristics of a PN junction or semiconductor diode. The circuit for this is shown here. It is the our PN junction. A ammeter, milliammeter is used for the measurement of the current that is connected in series. In a parallel, a voltmeter is connected to monitor the voltage. For limiting the current is a resistance here, and it is the battery, and it is the switch or K. Now what happen? The characteristics can be divided into the three categories. First, zero bias, second, forward bias, third, reverse bias. So when no voltage is applied, in case of the zero bias, no external voltage is applied to the PN junction as we have seen earlier, and circuit is open. This circuit, when no voltage is applied, the K is open. So current charge carrier will move due to the environment temperature only. No voltage is applied to the circuit. Now in this circuit we can say that the voltage, when apply the zero voltage, the current will also zero as shown on the this point O. Now in the forward region, what happened? Forward bias, we have seen that the forward voltage is applied. So initially when we increase the forward voltage, current will flow slowly, current will rise slowly. That will be in milliampere range. But after the forward voltage was 0.7 volt for silicon and 0.3 volt for germanium. That is called the potential barrier. After this voltage, what happen? The current will rise fastly. So we can see that after the barrier potential, initially our जो characteristics है, that is a non-linear as shown in the OA part. After that barrier potential, current will raise fastly, and that is shown in the AB region. Similarly, when no reverse voltage is applied, the P type of PN junction is connected to the negative terminal and N type is connected to the positive terminal. As we have seen that in a negative or reverse bias, what will happen? P type will be connected with the negative voltage of the battery, and P type, N type is connected with the positive terminal. So in this case, there will be junction resistance is very high, and a result no current flow through the circuit. However, a very small current of the order of microampere flow through the circuit in practice. So very small as shown in the characteristics, that current is microampere range. Very slow current is flow. But if we increase the reverse voltage continuously, then after these charge carriers get the enough kinetic energy and they break the barrier potential or they break the junction and current flow fastly, very fastly at this voltage, that is called the breakdown voltage. So that is shown in the figure. A reverse bias applied to the PN junction act as a forward bias to these minority carriers and has a small current flow in the reverse direction. If the applied reverse voltage is increased continuously, the kinetic energy of the minority carriers may become high to knock out electrons from the semiconductor atom. At this stage, breakdown of the junction may occur. This is characteristic by a sudden increase of reverse current and a sudden fall of the resistance of barrier region. This may destroy the junction permanently, as shown in the figure. So we can see that it is the VI characteristics of the PN जंक्शन डायोड. तो हमसे इसमें ये पूछा जा सकता है कि फॉरवर्ड बायस में, रिवर्स बायस में किस तरह से हम पीएन जंक्शन को कनेक्ट करेंगे और उसकी जो कैरेक्टरिस्टिक्स है पीएन जंक्शन की वो क्या होगी. तो वी हैव सीन दैट व्हाट विल बी द कैरेक्टरिस्टिक्स ऑफ द पीएन जंक्शन की कैरेक्टरिस्टिक्स को हम किस तरह से प्लॉट कर सकते हैं. That we have seen in this lecture. Thanks to all of you.